All right, in this video, I'm going to be working BC Homework 9.4, and this is kind of like a set of integrals, and we're going to be choosing the technique of integration. If you're in my class, you just learned about integration with completing the square, and there's a couple of these on there, but at this point, we know that complete the square is not the most important of our techniques of integration, and we're really just, kind of practicing a bunch of them all at once. So 1a is going to be the integral from 0 to 3 of the square root of 9 minus x dx. Okay. This is something that we can rewrite as a power. Okay, let's get my colors out. I'll say, all right, this is 9 minus x to the positive 1/2 power as I integrate from 0 to 3. Okay. And then I'm going to find an antiderivative by adding 1 to the power and dividing by the new power. Then I'm going to check for the derivative of the inside, and the derivative of the inside is -1, so I need to divide by -1 to prepare for the chain rule, right? And I'm going to double check to make sure I've got myself a valid antiderivative. Negative 9 minus x to the 1/2 times -1 for the chain rule. Okay, I'm satisfied. All right, 0 to 3, and that's going to be -2/3. Looks like this pen's running out of ink. Doesn't look like it, but whatever. 9 minus 3 is 6 to the 3/2. Minus -2/3 of 9 minus 0 is 9 to the 3/2. Okay? And that's how we would do that one. That blue one that I really liked, yeah, this one is working well for me. All right, the next one is integral from 0 to 3 of the square root of 9 minus x squared. That's another one we need to be able to recognize. Okay. Integral from 0 to 3 of the square root of 9 minus x squared. Okay, if you tried to anti-differentiate this, you would run into an issue. Whatever your purported antiderivative would be, I would just encourage you to take the derivative of it and see why it's not going to work. And you're probably going to have product, quotient, chain rule consequences that is not going to get you back to this, unless you do some sort of crazy trig substitution, which we don't do in this class. What we do instead is we say, wait a second, this is the equation of the top half of a circle. Okay, so I'm going to draw that circle. Looks like my pen went dry. But right, this is going to be, that's the square root of 9 minus x squared. Okay, if I've drawn it right. And if we're integrating from 0 to 3, that's going to be 1/4 of a circle. So that is going to equal 1/4 of pi times radius squared. We need to know that's okay. That's 9 pi divided by 4. Okay. Then I'm going to move on. 1c. Integral from 0 to 3 of 1 over the square root of 9 minus x. And yeah, okay. Okay. This one, I'm going to, just like the first one, I'm going to rewrite this as a negative power of x, but, okay, I do need to make sure that I'm not dividing by 0. Okay, if x was equal to 9, that would cause an issue for me, but that's not going to happen between x equals 0 and x equals 3, so this is not an improper integral. I don't have to worry or anything. I don't have to transform this to a limit. So I'm going to say this is 9 minus x to the -1/2 power, negative because it's in the denominator, and integrating from 0 to 3. Okay, I'm going to add 1 to the power, divide by the new power, and then divide by -1 to prepare for the chain rule. So -1 times 9 minus x to the -1/2 power times -1 for the chain rule gives me back my integrand. Okay, I've got a valid antiderivative. And I do that, and so it'll be -2 times the square root of 6 minus -2 times the square root, not of 0, but of 9, okay, when I plug in 0. And you could say that's 2 times 3 is 6 minus 2 square roots of 6. Okay. The next one, okay, the 1 over the square root of 9 minus x squared. But just the antiderivative. Okay, I'm glad I didn't put bounds on that one. Okay, this one is one where we're looking at it. If we tried to use the power rule, it's just not going to go that well. And it looks closest to something that I would use arcsine on. And I did one of these in class for you. And we're just going to, follow the same steps. We're going to factor on it, try to get it to look like the integral of 1 over the square root of 1 minus u squared, maybe multiplied by something. And then we'll probably, if you remember the pattern, then you could just probably jump straight to the antiderivative. But that won't last you very long, right? You won't be able to remember that 3, 4, 5 months from now. But maybe you'll remember about your algebraic manipulations. So I'm going to factor out a 9. And I'll be left with 1 minus x squared over 9. Solid inside the square root in the denominator. Okay, then I'm going to split this radical over the two things that are multiplied together and rewrite this as x divided by 3 squared. Okay. Then I'm going to use a u substitution. I'm going to let u equals x divided by 3. And du will equal 1/3 of dx. Okay. But I don't have du, I have dx, so I'm going to solve for dx real quick and say dx is 3 dus. Right? So where I had dx, I now have 3 du. And then I'll might factor out the 1/3, even though I know that 1/3 and that 3 are eventually going to cancel. 1 over the square root of 1 minus u squared times 3 du. And then I'm going to say, okay, those are going to cancel, and this is inverse sine of u. And I said u is x over 3, so that means it's inverse sine, arc sine of x over 3 plus c. Okay? These are not the most important integrals out there. I'm not going to put them on my unit test, but it's something that you should at least be aware of in this class. This type of problem used to show up not infrequently on multiple choice no calculator. Maybe it was just multiple choice before there was a calculator, but I feel like it's been de-emphasized, and I think the arctangent one is much, much more likely to show up on our exam this year. So, number 3. Integral of 1 over x squared minus 6x plus 9. Okay, this one, I can factor this. This is going to be x minus 3 and x minus 3. So I'm going to go over here, and I'm going to say, all right, this equals the integral of 1 over, that's not what I meant to do. Which is x minus 3 squared in the denominator, which I can write as x minus 3 to the negative 2 power. And then I'm just going to use the power rule, and that will make my life much easier. I'm going to take x minus 3, add 1 to the power, divide by the new power, check, okay, positive 1 times x minus 3 to the negative 2 power times the derivative of the inside is 1. That's what I've got here, and which is the same as that, so I've got myself an antiderivative. Okay. 1f is going to be, 1 over x squared minus 6x plus 10. Okay, and 5 and 2, 9 and 1. This isn't factoring right. Okay, you look at it, and it's like, I can't factor this. But it's just bigger than the perfect square by 1, so this is going to be my complete the square for, arctangent. So I'm going to say that this is the integral over x squared minus 6x plus 9, which I know is a perfect square, plus 1. Okay. And then I'll say that's 1 over x minus 3 squared plus 1. And then I know that the antiderivative of 1 over a thing squared plus 1 with respect to that thing, well, it's going to be arctangent of that thing. And so you could use the u substitution, u equals x minus 3, du equals dx, or you could just be like, okay, I've done a couple of these. Now I know that this is arctangent of x minus 3 plus c. Definitely we want to know that pattern, that bigger than a perfect square by just 1 pattern. All right. g is 1 over x squared minus 7x plus 10. That's x minus 5, x minus 2. I can factor that. The factors are distinct. So I'm going to use partial fractions. I'm going to break it down with the a and the b. So 1 over, I need to pick it right on. 1 over x minus 5 and x minus 2 is equal to a over x minus 5 plus b over x minus 2. It's not even on my shot. All right, so that means that 1 is equal to a times x minus 2 and b times x minus 5. Okay, I'm going to let x equal 5. And that gives me 1 equals 3a, a is a third. And then when x equals 2, I'm going to have 1 equals negative 3b. So that means b is negative 1/3. So I'm anti-differentiating. A is 1/3 over x minus 5 minus 1/3 over x minus 2. And then I'm going to do this, and this is 1/3 of the log of the absolute value of x minus 5 minus 1/3 of the log of the absolute value of x minus 2 plus c. I need some more paper to write on. All right. Then, okay, 1h is, oh, what's this sheet? Over x squared plus 8x plus 17. Oh, yeah. 17, that's not sounding promising. 17, it better be 19, or 18, right? It's 17 and 1, because I don't know any other factors of 17. But this is not it. And if you think about it, x squared plus 8x plus 16 would be a perfect square. So this is off by just 1. So I'm going to go over here, and I'm going to say, all right, this is integral of 1 over x plus 4 squared would be x squared plus 8x plus 16 plus 1. And so I know, if it's off by 1 from a perfect square, it's going to be the arctangent pattern. And so that's equal to inverse tangent of x plus 4 plus c. Okay. 1i is the integral from 0 to 1 of 4 to the t dt. And this is an antiderivative that we need to know how to take. Okay, it's definitely one of our more obscure antiderivatives, but all the same, it's one that we need. Okay, I'm going to get a different color. I guess purple will do. I thought I had an orange in here, but it must be just missing. All right, so the antiderivative of 4 to the t with respect to t is 4 to the t divided by the natural log of 4. Okay, and you can just know that, or I can show you, I'll show you after I work this one how I got that. Okay, but a lot of people, they're just like, you need to know the derivative and antiderivative of a to the t with respect to t. And that's fine. So this is equal to 1 over log 4 times 4 to the 1 minus 1 over log 4 times 4 to the 0, which is 1. Okay, so I get 4 minus 1 is 3 over the natural log of 4. If I was to combine these with, common denominator. Okay, but question being, how did you know that the antiderivative of 4 to the t with respect to t was 1 over log 4 times 4 to the t? So I'm going to rewrite, so suppose I want the antiderivative of 4 to the t. I'm going to rewrite 4 as e to the log of 4. And if I'm taking that 4 to the t, well, that's like multiplying the exponents. Okay? And if I was taking the antiderivative of e to the 3t, I know that would be e to the 3t divided by 3 to prepare for the chain rule. So I know that this is e to the log 4 times t, because log 4 is just a number, right? It's just a slope against t. And so I'm going to divide by that to prepare for the chain rule, and then I'm going to reapply that, fundamental identity of logs and say e to the log 4, that's still 4. Okay, so I got 1 over log 4 times 4 to the t plus c. Okay, that's how I got that. Okay. And yes, that is one that you need to know for AP Calculus. Okay? So you can either spend your time complaining about it, or you can spend your time learning it. and, well, I know how I'd spend my time. So 1j. Oh, yeah, good choice here. You should probably be able to do this one. So square root of 3 minus t all divided by 3. 3 divided by 3 is 1 minus t over 3. So I'm going to rewrite this even before I change into a color. Call it 1 minus 1/3 t to the 1/2 power. Okay. And then I will try to anti-differentiate this, right? I'm going to say that this is add 1 to the power, because it's linear on the inside. Then I'm going to divide by the new power. And then I'm also going to have to consider what's going to happen with this negative 1/3. I'm going to multiply by negative 1/3, so I really need to divide by negative 1/3. So I'm multiplying by negative 3 over 1. Okay, so I got negative 2 times that to the 3/2 as t runs from 0 to 1. Okay, so negative 2 of 1 minus 1/3 is 2/3 to the 3/2 minus negative 2 times when I plug in 0, I get 1 to the 3/2, and that's going to be a safe place for me to stop. 1k is the integral of 1 over 3 to the t dt, the antiderivative. Okay, I'm going to real quickly rewrite that as 3 to the negative t dt. And so I know that this is going to need to be very similar to the antiderivative of 3 to the t, except I'm going to need to prepare for the chain rule with that negative. Okay, so it's going to be 3 to the t, because exponentials are related to their own derivatives. I'm going to divide by the natural log of 3, and I'm also going to divide by negative 1, and I guess that's going to need to still be negative t. Okay, and you could always think of this, you could check your work by calling it e to the negative log 3 of t, and then just checking, it's going to come out, and that negative log 3 would cancel with that log 3 and the negatives, and you'd end up with 1 times 3 to the negative t. And I'll add a plus c. Okay, the last one for this problem set is 1 over the cubed root of 1 minus 2x, just the antiderivative. And I think this is a good one. Back to green, I suppose. And I'm going to rewrite as a power. 1 minus 2x to the negative 1/3 power. And that's going to be, I'm going to add 1 to the power. 1 minus 1/3, or negative 1/3 plus 1, is going to be positive 2/3, divide by 2/3. But then there's this negative 2. Okay, I know that if I take the derivative of this, I'll have 1 times 1 minus 2x to the negative 1/3 times negative 2 for the chain rule. So I just need to multiply by negative 1/2 so that, when that happens, I end up with 1 of these cube roots in the denominator. Okay, and then that would be plus c. And, if a person needed to clean this up a little bit, they could call this negative 3/4 of 1 minus 2x to the 2/3 plus c. And that's all for this problem set. I've got a couple of other, practice sets of, here, choose the technique of integration, UDU versus UDV, and all that would be good practice. If there's anything that you're noticing that you're weak on, that you're not seeing available in my selection of practice materials, you let me know. I will provide the practice and the solutions. So thanks for watching.